Okay, so in this video I'm going to be discussing logarithmic graphs and how to graph them and what they look like. So, without further ado, let's get started. So I'm going to be using a basic t-table that we did in previous videos and in previous skills of math to actually graph this. And so I've already plotted some positive numbers, and if you notice, down here I say actually, grammar sucks. No negatives. You cannot have a negative x, and that is because of simple exponent properties. Let me give you an example. If we have log base 10, right, log base 10, of negative 1, well, you can't really do anything. So 10 to the power of what will give you negative 1? Alright, there's no actual power, or there's no actual x value that can give you a negative y output. And you can see this in the graph. When we do our graph, I can show you why this is so. So our 1 will be simply 10x equals 1. And then 10x is going to be equal to 2, right? And we're going to have 10x is going to be equal to 3. And if you're wondering how I got this, I'm just converting the values that you would have if you've plugged it into this x. I'm converting it to exponentials. So, look, maybe you might be a little confused on what I did, and that's fine. Don't worry about it. If I can find some space here, I can show you that this is the exact same thing as this on the bottom, right? So y is going to be equal to log of 1, or right? Log base 10 of 1. And that's the same thing as saying, when we convert into exponentials, 10 to the power of x is going to be equal to 1. And so that's my rationale. So you can see it a lot like this, and I'm doing real world applications. So when your test comes, or when your test in life comes, you will be prepared, and you'll be armed with the magnificent sword of knowledge. Okay. 10 to the what power is going to give you 1? Well, simple exponent stuff, that's going to be 0. Any non-zero to the 0 power is going to give you an output of 1. How about I do this in a red color? 0. Right? And we can already plot this actually. So our x is going to be equal to 1 and our y is going to be equal to 0. So we can just plot this like this. Only I could write a little better. If only I could write a little better, right? Okay, that's much better. And this is going to be equal to a number that I've already done in a calculator, because it's a little hard to do, or very hard to do, nearly impossible to do with your imagination or your mental skills, right? And so that'll be 0.3, approximately 0.3, and if we have 3 as the x, that'll approximately be 4.8. Looks like a negative. Okay, 4.8. And so let's plot these values. Dun, 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 dun. Okay. Alright. And we'll have a 2. And that'll be around really close here to here. Actually, I'll put it like this. It's a little too high, but whatever. Okay, 3 is going to be 1, 2, 3, 4. Right? 4. Or actually, it'll be 4.8. Oh, well, I need a break after this, don't I? And essentially, it'll be like this. This is going to be your graph. It's going to keep getting close to this y-axis, but it's never going to actually touch it. Let me give you an example. I've done it in a graphing calculator. I've done this stuff here. Okay. Maybe you can see it like this. You can see here that it keeps getting closer. And of course, the link to this graphing calculator is going to be in the description, because I don't want to be doing plagiarism or anything, right? Keeps getting closer and closer to the y-axis, and that's the main cool thing about logarithms. We're going to be approaching this idea in more advanced ideas, such as geometric sequences that have something similar, and ultimately limits and derivatives. Okay, let me not get too ahead of myself. So we have all of this stuff here, and now what we need to do is find the domain and the range. So in a function like this, when you don't have anything affecting the x, then your domain is obviously going to be x is greater than 0. let me do this in a different color for y'all. Oh, using slang, huh? So x is greater than 0. Yep. And therefore, you can see this here. It'll keep getting closer to 0, but it'll never actually touch it. And so therefore, your x-axis can be anything above 0. So, what about the range? In this function, it goes forever. Look, you're touching every possible y-axis. Tick mark, right? So, let's say I kept adding tick marks here, tick marks. We have these arrows indicating that it'll go on forever and ever. And this is basic geometric stuff that you learned probably in your freshman year, but it keeps going forever, it extends indefinitely. Therefore, your range of this will be all real numbers. And I hope this was really helpful to you, so I'll catch you later.